Okay, so can you open your camera so that we can have better communication? Thank you very much. Thank you. Yeah. So this is the second slide in Google Classroom. In artificial intelligence for business. We have discussed last meeting, right, about the pattern. I hope you still remember this. Okay, and some little statistic here. So, is there any question about last week meeting? Yeah, not so. Let's continue. Okay, so today we discuss about data mining and pattern recognition. Okay. Okay. So, yeah, this is the overview for data mining. Okay, so some key steps in data mining and the terminology that we often use. Okay, when you hear machine learning, right? So what is learning there? And at the end of this data mining lessons, I will show a little bit about trading analysis. Okay. So the key steps in data mining is, of course, you start with what is called problem definition. Okay. So for your group project, you will start with definition of what you are going to make. Okay. So what kind of business, for example, that you are going to go in. And of course, next is to collect the data. Right? The next step is to collect the data.
Asik, oh asik ya asik. Hah?
I think one of your mic is. You can close it if you can. Okay, next is about pre-processing. Okay, pre-processing means there are certain cleanup on your data. And then you do what is called feature extraction. So when we talk about PCA later, okay, principal component analysis, this is to extract some features from the data. And then you do what is called pattern recognition, or sometimes we call it machine learning part. This is the core component of machine learning or data mining. Okay, and then of course you do some post-processing, which is to put your output, okay, to be readable by human, and do some evaluation and interpretation. Okay, so in problem definition, you will ask these key questions. Okay. What is the system of interest? That means you will develop a system, right? And what will be the system of interest that you want to create? And what is the goal? Okay? What is the goal of the analysis? For example, you want to distinguish certain songs, for example, or you want to know the genre of certain poem, for example. It's up to you to decide what topic you want, but the goal must be clear. Okay? And then how could we describe different state of nature and classes of observation? That means you have certain data that you want to collect. Okay? What are the variables there? And then you need to have a kind of output from this data. Okay, so we call these classes, okay, or a category of the data that you want. And what kind of data that may be relevant for this kind of analysis, and how you can gather that data. Okay, so these are the key questions in the first step, which is problem definition. In the second steps, okay, with this data collection, then you ask this question: what data is available to collect? Okay. What additional necessary data is needed and how to collect? So this is crucial because the data that you will collect can be continuous. For example, you get it from internet, for example. Then this kind of data collection means you need to create a book to collect the data, correct? Or you want to collect only certain data that is finite, meaning a few data that after you collect, then you analyze, but it doesn't make it continuous. Okay. In that case, you will ask how many data points is needed. And another crucial question is, if you have a data, okay, and all these variables that you already set, okay, how about if certain data is actually not available and missing? How are you going to deal with the missing data? Are you going to delete the whole record? Or are you going to impute certain cells in the data? Next is to do what is called pre-processing. Okay, so very important. How are you going to do the pre-processing? That means you need to segment the signal from the noise. What is the meaning? Okay, the meaning is like this. Your data is equal to signal plus noise. Okay, data is equal to signal plus noise. Noise means something that you don't want. Okay, something outlier. Okay. Then the question is, how are you going to filter the noise out of your data? Okay, so there are two types of noise usually. Okay. One is high frequency noise. The other one is low frequency noise. That's why the pre-processing step usually have two kinds also. One is called low pass filter, and the other one is a high pass filter. Okay. So I give you example. In image, okay, in image, sometimes there are certain dot. Say, look at this image in Zoom, for example. There are certain dot, okay, some noise that you see, okay, and you want to remove that. How are you going to remove that? So that one we use what is called low pass filter. So it will become blurred. When you move your head like this, for example, there are certain blurry, right? That is there is certain what is called low pass filter going on there. Okay. And if you want to sharpen it, okay, that kind of thing is called a high pass filter, because there is a high frequency that you want to sharpen. Okay. Another pre-processing usually, again, dealing with the missing values. Yeah? Some data you have collected, say you have 10 variables. Okay, 8 variables are filled up, but 2 variables are not filled in that several record alone. Then what are you going to do? You will discharge the data, or you are going to impute. Impute means you fill up the missing values. How are you going to impute? Usually we impute by deciding within that variables what is the median value. Okay, so if you have missing data, then you calculate the median value, and then that missing cell will be imputed, meaning you input manually with the median value, so that all data will be filled up. Okay. So far, any question? And after that, okay, the next step is called feature extraction. Okay, so in this case, you transform your data into several indicators. So this is called secondary data. It's not from the data that you collected, but you derive. I give you an example. So if you have a profit, if you have a sales and cost, right? If you have sales and cost, that is the data that you have. Then you can calculate profit as a new field, right? So there is a new data that you can create based on the data that you have collected. In fact, this new data that you collected in new variables, okay, is probably more than the data that you have made. That's the first step. After that, okay, after you create so many variables, then you want to reduce it. Why you want to reduce it? Okay. For certain analysis, for example, like machine learning or pattern recognition, okay, for statistical analysis, there is no problem, you increase the data. But for machine learning and pattern recognition, if you use the variable, some data of the variable that actually correlated, highly correlated, okay, then you will have biased result. So you have several variables, for example, x1, x2, x3, x4. Yeah, if some of these x actually overlapping or correlated, just multiply of each other. For example, x2 is actually 3 times x1. Okay, so multiply of each other, then whatever analysis that you make, okay, the result will be very good, but it is useless. Okay. So if your data is actually highly correlated, they are actually the same data. Okay. So if they are actually the same data, you need to remove so that each of data is actually independent of each other. That is the basic assumption of pattern recognition data mining. Okay. We call this IID, independent identical distribution. So they must be independent. Between variables must be independent. But unfortunately, real world data sometimes correlated. Okay. So in that case, you need to reduce. You need to remove some of data. Or another way, for example, you use PCA, instead of reduction, you rotate the data in another space so that they are independent to each other. Okay. So there are certain, depending on your data, there are certain things that you want to make it invariance. For example, if your data is image, okay, you want to make the rigid body, for example, human or a car, to be invariance toward translation, toward rotation, and scaling. Right? So this is called a rigid body transformation invariance. So you don't want to be rotated and then the shape change. Okay? You don't want to be scaled and then the shape destroyed. Okay? Sometimes in your feature extraction, you want to discretize. Okay? Your data is continuous, for example, a real number. Then sometimes if your data analysis is actually need to use only discrete values, then you discretize. Another method of transformation is called normalization. Normalization has two meanings. Okay, the first meaning is mathematical normalization. The second is statistical normalization. What's the difference? Okay, mathematical normalization means, okay, you normalize the variable value into 0 and 1. Okay, the range of the variable, for example, between 1 to 1 million, and then you suddenly normalize it into an index between 0 to 1. Why? Why do you need to normalize? Okay, because if your value is too big, then that variable will be dominant, right? Compared to other variables. Then your analysis is useless, correct? Because one variable is too dominant just because of the units that you use. One is, in Indonesia, for example, rupiah is very big, right? Okay. But actually the value is little. Okay? For example, 1 million rupiah is actually less than $100, right? So the same thing, if you use meter and then suddenly you change it into centimeter or millimeter, suddenly your numbers become very big, then become dominant, correct? So your unit must be the same. Okay, so using normalization, okay, how do you do mathematical normalization? Easy, yeah? Your value minus the minimum divided by the maximum minus the minimum. Okay, so then you will have a value between 0 to 1. That is the first one. The second one of normalization is called statistical normalization. What does that mean? Meaning your data, okay, will be transformed into a new data set which has mean of 0 and standard deviation of 1. How do you do that? Of course, you minus it with the mean, arithmetic mean, and then you divide by the standard deviation. Okay, so next is to do what is called feature selection. Okay, then you will select, for example, which variable actually has the largest variance, the largest variation that will explain the whole data. Okay. Before this, is there any question? Okay, so next is to do what is called pattern recognition, okay, or machine learning itself. Okay. There are choices of algorithm that you want to use, okay, depending on the purpose. Okay. One is called regression analysis. So usually we use this in the economic. Anyway, if you check our Google Classroom, we have one slide represent the regression. Okay, we will discuss it next time. Okay, and we will also discuss in more detail about supervised learning, as well as unsupervised learning and association. Okay, so in brief, what is this? Okay. Regression is basically supervised learning. Okay, you have data, okay, and you have, say, you have data which consists of input and output, right? Your input can be any kind of data. If your output is numerical data, remember, if your output is numerical data, real number, okay, ratio type, then you use regression. Now, next you have data, your input, the independent variables, are actually any kind of data, and your output is actually categorical or ordinal data. Ordinal data is like preference, 1, 2, 3, 4, 5. Yeah. Like or dislike. Yeah. Nominal categorical is like, for example, the color of your eyes, postal code, and so on. Okay. That part, categorical data, then you will use what is called supervised learning. Now, if your data does not have any output, only input, okay, and you want to find the structure within the data, you don't have any output, only input, then you will use what is called unsupervised learning. Okay. Now, next, if your data is actually both the input and output are categorical and you want to find the association between these two data, how often one happen and then the others also happen, that is called association. Okay. Once you have that, then you will do what is called training or what is called calibration. Okay, I will discuss about this for a while, a little more. And then you will do what is called validation. Okay. And check how accurate it is. Okay. Next is do what is called post-processing. Sometimes post-processing have two meanings. Okay, one is to check the cost, okay, of your analysis, and next is to verify your result, okay, whether this is actually makes sense or not. Okay. And the last step is to evaluate and to interpret your result. Okay, so check whether you want to understand the phenomena or to predict or to control. Okay, again, come back to the beginning. Okay, do we meet the goal of the analysis? Is there any new surprise? What you can learn from it, and then do you still need to refine the process and so on? So then, if yes, then you need to come back to the beginning. You define the problem again. Okay, so this is the general steps that you can use in data mining. So is there any question about these steps? Okay. So if not, so we discuss what is learning. Okay. So suppose you have a system. Okay. Then we say that a system learn a pattern. Okay. If that system encode that pattern into its structure. Okay. So the system structure changes as the system learn the information. So this is the definition. But look at it into a simple example of regression here. Okay. This is the terminology. Okay. Sometimes you will see, oh, come on, only that. Okay. Okay. So suppose you have a table. Okay. This is the table of the car price. Okay. Depending on the number of months, kilometer, and the price. Okay. Okay. Now, the output, of course, the price. Okay. The input will be the age of the car. Okay. This is clearly used car, right? So the age of the car in number of months and how many kilometers in the speedometer. Okay. You can check that. So say suppose you have only 10 data. since the output is the price and the price is actually a real number, so we use regression, right? So this data that you use is called training sample. Okay. The regression analysis that you use is called learning algorithm. In this case, for example, I use singular value decomposition or SVD. Okay. So when we say learning, okay, what is the meaning of learning again? The system learns a pattern if the system encodes the pattern in its structure. Okay, what is the system? The system is your regression model, with its price equal to A plus B times the H plus C times the kilometer. Okay, and it's a system learn a pattern. What is the pattern in this case? The pattern is your data, okay? Your training sample. Can you see the terminology here? Okay. Next, the system learn a pattern if the system encode that pattern, which is the data, into its structure. What is the structure here? The structure here is the parameters, which is A, B, and C. Okay. So when we say the system learn, that means calibration. How do you calibrate? You have the input, you have the output. Okay. Then you put it into the algorithm. What you will get? You will get the parameters. Right? You will get the parameters. So what are the parameters here? The ABC. So up to here, is there any question? So what is the, if learning, then there must be a teacher, right? So the output is called the teacher. Okay. In this case, the price. Okay. So using this paradigm of learning, so the learning itself is not really learned, okay? It's just a paradigm. Okay, so look at the terminology. When we say training, learning, okay, it's basically calibration. When we say teachers, it's basically the output, which is the desired response. Okay, when we say pattern, training samples, what is that? Data, the whole data set, input and output. When we say system, what is that? The model itself. When we say structure, what is that? The parameter, the weight. Okay. So in general, there are three main learning paradigms. Okay. So we have what is called supervised learning, unsupervised learning, and reinforcement learning. Okay. So in supervised learning, you have the input, which is X, and you have the output. Okay, in this drawing, the output is F. Okay, and what happens is if you have the input and the output, it is the teacher there. Okay, then you put it into the system, it will learn. Okay, the rule. What is the learning part there? The W. Okay, the W here, if I put it into the previous slide, okay, W represents the factor of A, B, and C. Okay. So if you have the input and the output, okay, and you want to get the parameters, that is called supervised learning. Okay. Second, in the middle, is called unsupervised learning. What is this? You have the input, right? But you have no output. Okay, you have the input only and you have no output. So what's the teacher there? The teacher is the input itself. Okay, and then you want to create clustering. So we want to create clustering. What is this data can be structured into some kind of cluster grouping. Okay, so this is called unsupervised learning. There are two types of unsupervised learning. Okay, one is called partition. Partition means we separate the whole data set into partition. There is no overlapping between one part and the other. Okay. Second, usually we have what is called hierarchical. So there are overlapping between one part and the others. The third part, the third paradigm of learning is called reinforcement learning. So in reinforcement learning, you have example of situation, but you don't have the exact answer. Okay, so you don't know what is the rule. Example of application of reinforcement learning. Say you want to create a machine that can learn to play chess. Okay, in that case, you will not use supervised learning. You will not use unsupervised learning. You will use reinforcement learning. Okay, how to do that? You give the machine examples of the situation, right? So many examples, okay? Millions of them. And then gradually the machine will learn to be better and better, right? And it will discover the rule of chess itself. Okay. So that's what reinforcement learning is about. Okay. Of course, there are models on it, yeah, that when you put it in, it will improve and getting better. Okay. So up to here, the paradigm. Is there any question? Okay, so earlier I talked about the usage here is 3. Yeah? Understanding phenomena, prediction, and control. Did I explain about this before? Okay, I will share my whiteboard. Okay. So there are 3 levels. Okay, level 1, level 2, level 3. Yeah. Level 1 is called understanding. Understanding. Oh, my writing is so bad. Okay. Level 2 is called prediction. Level 3 is called control. Okay, understanding phenomena. What is this? Suppose you have a function. Okay, y is a function of x. Okay, what is this? This means you have input x and you have output y and your model or the system f. And of course, you have what is called the parameter. I call this alpha. So understanding phenomena mean what given, okay, x, comma y, which is your data, right? The input and output, okay? And then you assume F, the model must be assumed. What you will get, learning, is to get alpha, which is the parameters. So in regression analysis a while ago, alpha is the parameter A, B, C. The X in here is a vector or a matrix of price and age. The Y here is the price. Okay. The function here is the regression function, which is price equal to A plus B times what a while ago. B times what? B times age and C times kilometer, right? Okay, so this is what is called learning. Understanding is called learning. Okay, this is the first step. After that, you want to use what is called prediction. In prediction, what you have given. What is given here? The given is, of course, the X, the input. It's a new X, okay? And you also have the function and the alpha from the that you have calibrated. Okay. And what is the output? The output is the Y. Okay. So given your input, and I assume the function and the calibrated parameters, then I will get the output of that input. Okay. The third usage, okay, is actually to control. What is the meaning of control? So that means given, okay, again you have the F and alpha, this is given, okay, and given the Y is your target, then what you want to get? What you want to get is the X. Of course, this is not possible unless you have what is called inverse function. Okay. The function is not the function itself, but as inverse function. Okay, up to here, is there any question? Okay, understanding of learning means you get the parameters. Okay. I'll show you again the example a while ago. Okay, understanding means you have the parameters. Okay. So with this ABC, this is the alpha. Okay. And then prediction mean what? Prediction means you have a new X. You have new car with this certain age and certain kilometer. You want to get the output, in this case the price. Right? Control, what does that mean? Meaning, if I know I want to buy a certain car, okay, of certain price. Okay. Now give me the input. What age and what kilometer? Okay. That is called control. So up to here, any question? So next I will demo a pattern recognition. Okay, so I use this, say I use a supervised learning, say of K and N, okay, on a single stock, for example, Microsoft or Yahoo or Google, okay? Or you can use one Indonesian stock, for example, PCA or Telkom, whatever, okay? And the X will be the date, and the Y will be the price or the volume, okay? And we calibrate the parameter of K and N. It is K. It is 1 to, say we set 1 to 25, okay? And we do validation using what is called two-fold validation. And to measure the accuracy, we use sum square of error. Okay, the data is actually available over the internet, which is daily data, consists of the date, open, high, low, close, and the volume, and adjusted close. Okay, these are all the price data and volume. Okay, and then we do what is called pre-processing. Okay, so the actual data will be sorted from the oldest to the newest, and we use the adjusted close, okay, to get the actual price. Next, okay, we use 5 features. In this case, opening price, closing price, the highest price and the lowest price, and the volume to forecast. Okay, these are the 5 features. And then we use learning, which is to calibrate the parameter K. Okay, so K is running from, in this case, I use MATLAB, so between 1 to 100, and the lowest of sum square of error will be, say, K, for example, 93. Okay, and then we check whether the K is actually the same for each type of price or not. Okay, apparently they are not. So if you use closing, for example, K is 1, the minimum. If you use opening price, the K is actually minimum at 3. High price, for example, the K is 2, and so on. And then we use validation, n-fold validation, okay, to get the, again, minimum sum square of error, okay, for each n, for each n in here is the n-fold. Okay. Then we check what is the parameter. So apparently the parameter K is stabilized at K equal 1 and K equal 2. Okay, and then we evaluate because we don't have post-processing here. Okay. Finally, we check this is the actual parameter that we will use in this table. Okay, and then we do forecasting. Say we initialize it with say 100 price data of price and volume, and then we repeat the whole process to forecast the next day or a few days later from today. Okay, and then we check the forecast error. Okay, and as the result, I try to compare K and N with this machine learning method with a simple moving average. Okay? And the blue one is the true value. You see here is actually shifted between the true value and the K and N. And the K and N, then a moving average is exactly the same. So then we can conclude that actually K and N for time series data is exactly the same as moving average of K plus data. In that case, it is easier to use moving average than to use K and N in terms of computational. Okay. So I will do another demo here. Okay, let me share my screen. Anyway, before that, you can visit my website in referedu.com, peoplereferedu.com, and you go to the free online tutorial here, and you can see a lot of tutorial in Python, PCA, neural network, decision tree, and so on. Many of my slides, I took it from my own tutorial here. Okay, so you read on your own. So here I will demo the trading experiment that I'm doing. So this is the simplest one. Let me change the network. Can you see it? This is called a channel breakout. So we set a certain threshold, okay, up and down. And then we simulate the price over time. Can you see it? So there is no prediction here. Okay. Next, close this. Okay. Can you see the animation here? So in here, I check. What is this? Okay, I created the pattern, okay, based on the data. So if you look at this, half of this the half of the pattern on the left are the actual data that is inputted, okay, and the green part is actually the prediction. Okay. Of course, they are using a simple linear equation. With prediction is simply extending of the line. Okay. Okay, I will close this. No, this is finished. This is another way of doing. Okay. This is more sophisticated pattern that we develop. And you can see the pattern is more complex and the prediction is also more complex. The green one is the prediction. Next. Okay. This one. And this is the next demo. Okay, so now I use a more complicated pattern that we develop. And you see the red one is actually the pattern of input, and the green one is the output, which is a prediction in this case. It's pretty good, right? The prediction is not that bad. And we can compare, okay, the prediction with the actual price. Can you see it? Okay. So next demo is to compare several strategies. Okay. So here is with the computation. So of course, with this now we have simulation of auto trading. Okay. So when are you going to buy? When are you going to sell? And whether actually we have profit or loss. Okay. And if you look at the balance here, it's actually increasing over time. Okay. Maximum drawdown represents the risk. Right. Okay. So is there any question? Comments probably? Check clear? No question at all. Okay. So then let's continue. Okay. So we'll go to MATLAB. Okay. So the next part that we want to discuss is the pattern recognition itself. Okay. Let's see. There are many algorithms that we can choose, right? The question is simply, which one is the best? Is there any reason that you prefer one algorithm over another? So there is a principle that we call this Occam razor. Okay. Occam razor will give the principle to select among equally best algorithm. Okay. So say I give you example here. Say you have an input of x and output of x, fx, and the dot here, the symbol of plus dot here represent the data. My question to you is, what is the function to approximate this data? What will be the best function to approximate this data? So first, I will draw a linear function, the black one. Okay. Second, I will draw a quadratic one, which is the blue one. Okay. Next, I will draw the red one, which pass all the points. Okay. And next, I will draw the green one, which again pass all the points. Now, my question to you, which of the four models will you choose to represent the data that we have? Okay, raise your hand in Zoom, okay? Which one will choose the black model? How many? How many will select the black model? One? Only one? Only one? Or even why?
Because I think it is having the better certification. If we can like eliminate that one outlier, then I
Okay,
think it will give us the best results.
okay. So you think there's only one outlier? I will just remove that. Okay.
Yes.
Okay. Who will choose the second data, the second model, which is the blue one? Raise your hand. Oh, two. Only two? Okay, Nicholas. Why?
I think the blue one fits better, and I guess
Why is it better?
it compensates the furthest data. So I guess it could be better than the first one, which has the higher certification because of the outlier.
So Nicholas does not assume that this data is actual outlier. So then the blue one will be better. Right?
Yes.
Okay. Who will select the third one, the red one? Come on. Nobody?
I think I'm the blue one.
You're the blue one. Why?
Um, I don't know. Just
Why,
guessing.
why don't you choose the red one? It passed all the points.
Oh,
Isn't that better? No?
no idea.
No
But
idea. Okay.
something is right.
Something is not right.
I think the red one is overfitting, so the alpha is very short.
Oh, tell me what is overfitting?
Oh, Kanis, I think Kanis can tell what is overfitting.
Why can't it? How about you?
Well, from what I understand, overfitting is something that when the alpha is so small, so they like give the exact results to the data.
What is alpha in you?
Sorry,
What is the alpha is so small?
probably because the number of data is small, or well, that's what I understand. I don't understand much.
Your answer is correct, but the explanation is confusing.
Yes, used as well.
Right. Okay. So how about this green one? Surely not, right? Yeah. So if I should choose, I will choose the blue one also. Okay, you're correct, but because the red one and the green one is clearly overfitting. Okay, okay, there are two types. Okay, of approaching to model the data. Okay, one is called approximation. The other one is called interpolation. Okay, the purpose here is approximation. What is approximation? Approximation is useful to predict, okay? Go beyond, to extrapolate your data. Okay? You have the data, you want to go beyond your data. Extrapolation. Then you use approximation method. So, for example, regression. So in approximation method, usually there are some error. Okay. Now what happened if your model is actually passing all the data points? Okay. Okay. Like the red one here, right? In this case, okay, this is very good what is called interpolation. Okay. So instead of approximation, another one is interpolation. So in this case, you can interpolate the value between data. But this red model, okay, as you mentioned earlier, is overfitting. What does that mean, overfitting? Meaning that, yes, I can interpolate perfectly within that scope of the data, but I cannot extend it beyond the data. That means I cannot predict correctly, right? So a model that overfit means they can only be used within that scope of the data, but cannot go beyond. That is something that we don't want, because that means only in the first step, it is only to calibrate, right? But you cannot actually predict. You cannot even control. Okay. So Occam razor. Okay. So Occam is a Franciscan monk in 12th to 13th centuries. He said in Latin, and if you translate in English, become plurality should not be posited without necessity, meaning that if you select, okay, prefer the simplest hypothesis which is consistent with the data. So if two theories explain the fact equally well, then the simpler theory will be preferable. Okay, so in earlier, we select the blue one or even the black one, okay, because they are actually simpler, okay, to explain the data that we have. Okay. So, yeah, there is a theorem called Weierstrass theorem. Okay. Weierstrass theorem said that if you have data, okay, I can approximate your data. If you have any data, practically, I can approximate your data using polynomial of any degree so that it will be overfit. Okay. So that it will be passing all the points. So the theorem guarantee that only using polynomial, okay, then you can approximate any data in the continuous function. Okay. Here is an example of another system. Okay. To test, okay, whether the species of fish is actually sea bass or salmon. Okay. So there is a conveyor belt, okay, and there is a camera, and using the optical sensing, which is the camera, okay, we want to know whether the fish that passed there is actually a sea bass or salmon. Okay, so the price of sea bass and salmon is totally different. So then they want to separate them. Okay. When the fish coming from the ship, a lot of fishes. Okay, so this automation is very important. Okay, the same thing that we used the set a while ago. So you do a pre-processing and feature extraction, and then we do a pattern recognition or classification here. Right. So when you set up the camera, okay, take a simple image, then you need to extract the features. Okay, what are the variables that you want to use? Okay, there are many possibilities. Okay, for example, the length of the fish, the lightness, the width, okay, the number and the shape of the fin, and so on. Remember, we use just camera. Okay, so you can suggest any features to explore, okay, in your own classifier. Then we do pre-processing. Okay, we do what is called segmentation to separate the fish from the background. Okay, so you get the in the camera you have foreground and background. The foreground is the fish, the background probably the tray. Okay, then we use this information from every single fish. Okay, go to what is called feature extractor. Is another system. It's a software called feature extractor. What is the purpose? The purpose is to reduce data, okay, by measuring certain features here. Then this feature will be passed to the classifier. So let's say you have selected only length of the fish, okay, to check whether we can discriminate salmon from sea bass. So then we throw the distribution of salmon and sea bass based on the length. Okay, on the vertical axis you have the frequency. On the horizontal axis is the length, say in meter or centimeter. Oh, in centimeter. Okay, and if you look at the distribution, they are overlapping, right? So salmon and sea bass, if you use only length, you cannot distinguish. Okay, So the dashed line here is the actual separation, but so many error, okay? So many error. You look at the red part in the left, that means their CBAS predicted as salmon, and the black part of the distribution on the right, that means they are salmon that predicted as CBAS. So this is wrong. Okay, so length is a poor feature if you use it alone. Then we said, okay, let's add another feature called lightness. Okay, the color of the. Again, if you use lightness, okay, and check the distribution, oh, they are better. The overlapping region are actually smaller. Okay, then you can move the decision boundary, okay, so that the smaller value of lightness will be used in order to minimize the actual cost. Okay, so you want to reduce the number of CBAS that are classified as salmon. Okay, then you said, how about if I use both? So if you want to use both features with this lightness and the width of the fish, for example, then you put them into a factor. Okay, so for each fish, you will have xt transpose, with this x1 represent the lightness value and h2 represent the width of the fish. Okay, and if you plot it, okay, you can start to see, okay, we can actually separate them with a decision boundary of linear. Okay, so this is used what is called LDA, or linear discriminant analysis. Okay, so next, you may think about what is the optimal, okay, the optimal classifier. Okay. The optimal one is this. Okay. So we use very high degree of, for example, you can use SVM and so on. You will get exactly like this. Okay. What happened? It's clearly separate, right? Salmon and CBAS. Will you be happy with this? Yeah, this is the problem of overfitting happen. Okay. Now look at the arrow, the question mark part there. Is that actually CBAS or salmon? We don't know. Okay. Within the region of this boundary, you will say this is a CBAS, but we don't know whether this is actually CBAS or salmon. Okay, so our satisfaction with the new model, which actually overfit here, okay, is premature because we want to classify the novel input correctly. So we want to generalize the system. Okay, and this is clearly overfit. We cannot predict correctly based on this model. Okay, so then we can improve. Instead of linear, we can use non-linear, with this, in this case, quadratic. Okay, and you will have a fewer error. Okay, and this is probably the optimal trade-off, okay, of the model that you will use for the decision boundary. Okay. So this is what is called the problem with generalization. Okay. The risk of empiric, which is from the data, does not imply the small true risk, okay, of the expected risk that you have. So again, we use the same technique as a while ago. So this is just different name, but actually same thing. Okay, so don't forget to collect the data. You use many sensing devices. Okay, so you can use camera, you can use microphone, or any Internet of Things that you want. And the system depends on the bandwidth, there is resolution, sensitivity of your sensing devices. Okay. So our goal is to well separate the pattern of the distribution. Okay. If possible, do not overlap. If they are overlapping, then the overlapping must be minimum. Okay. And after that, you need to find the correct features, the correct variables that actually can discriminate, can separate the data into the correct class. Okay. And don't forget to use invariant features. These features must be invariance against, for example, rigid body transformation, okay, which is translation, rotation, and scaling. Okay, there are some descriptors, some features that are actually sensitive to translation or sensitive to rotation. Then we probably cannot use them. Okay. Once you have this, then you assign this vector into category, and finally you do post-processing. You select among all of this based on what is called loss function, okay? Or you can do cost-benefit analysis within several possible input and output that you have. To explain the loss function, okay, if you have several variables instead of just one variable, so your distribution is no longer just one normal distribution like this, but we have 3D, okay, something like this. Say suppose you have two features, okay, then you will have what is called joint probability distribution. Now, to calculate the empirical risk, then you need to assume some joint probability distribution. Okay, and don't forget, when you use the training data, okay, that training data have assumption that is IID. What is IID? Independent identical distribution of that joint distribution, okay, of that joint probability distribution. Okay, so your data is always sample. Okay. Sample of what? Sample of a certain population. What you want to get is actually the joint probability distribution of the population through your training data. Okay. Once you get the result, say, suppose the predicted result is X, okay, then then you can define any loss function, okay, any loss function. In the next slide, I will show you what is one of possible loss function. Then you can calculate the expected risk using example of this formula. Okay, so loss function times the probability distribution itself. Then you want, of course, your goal is to minimize the predicted result of the risk. Yeah? You want to minimize the risk. So this is example of loss function. You see here, okay, we have the actual on the left side and you have the predicted on the column, okay, and then you fill up the values there. If it is rain and rain, okay, if it is correctly predicted, what will happen? Okay, what will be the loss value, the cost of the, okay, if it is incorrect, what will be the cost of that? Then this is what is called loss function. Okay, a cost for each possible values between the actual result and the predicted result. Okay. Okay, so in reality, okay, there are certain cycles that you need to go up and down. For example, you collect the data, you choose the features, and probably not enough to discriminate, then you come back to collect the data. Again, you go to the choosing the model that you want, okay? At certain point, it's not good enough, then you select the features and then new features again, and then you collect the data again. Okay, so these are actually a cycles rather than just one way down until evaluation, okay? So, yeah, the rest you can read on your own. So, up to here, I want you to discuss rather than just reading this slide. Go ahead. So what did you learn today? Can you open your camera, please? Yes.
I learned. It's not like the learning, just remind me of more.
Candice, I cannot hear you.
How about now?
Yeah, okay.
So I think I not actually learning, like remembering statistics from from semester 2 or 3 again, like overfitting. Basically remembering the terms that I kind of forgot from opening like tab or Python. I'm kind of focused on SQL. What I learned today.
I think your voice is choppy. Can you hear what Candice is saying?
No, I think it's better to type.
Okay, you can type, Candice. Sorry. Yeah. Any other comments?
Hello? How about now, sir?
Yeah, okay.
Better. Okay. So I kind of like not actually learning for me.
Miss typing, miss.
So better.
It's better.
Yeah. Okay. Okay, while he typed, is there any other comments? Okay, what did you learn? Is there any
Classification.
sorry?
We learned about classification.
Okay, so you have learned this in statistics. That's what you want to say.
Yeah, I did. But
Okay.
like so long, like
So long ago. Okay.
I kind of like stuff.
Yeah. So basically, okay, when you heard the name, okay, data science, right? Okay. Oh, machine learning. Okay. They keep inventing a new name. Okay. Oh, big data. Right? And now they changed into artificial intelligence. Okay. Well, they're actually the same thing. Okay. Before, this is called pattern recognition. Before that, after that, they call it data mining. Okay. Long time ago, before determining exists, before a pattern recognition exists, this is called multivariate statistics. So basically, this is statistics. Okay, but over time we add more features. They said, "Oh, this is not statistic because now we have neural network." Okay, okay. So, well, again, the basic idea is still the same. Okay. And what I want you to remember in this lesson is actually the terminology of what we call it as learning. Okay. The learning paradigm. So sometimes we said machine learning, what is learning there? How can machine learn, right? So when we said learning here is basically just calibration. Okay. And the steps are normally, this is what you are doing. Okay. So we still have half an hour. Okay. And because this course is about artificial intelligence for business, it's not just artificial intelligence. So I don't know how to put the business part there, right? So then I add a new addition there, okay, with this blue ocean and brainstorming. So we will do brainstorming next meeting, but today I want you to do the blue ocean. Can you open the slide of blue ocean there? Where is that? So close, open new one. Okay. Okay. The blue ocean. Okay. So the blue ocean strategy, okay, come from a book, okay, called Blue Ocean. This is a quite well-known book. Now, our goal here today is to kind of brainstorm. So you brainstorm within your group. Okay, you brainstorm within your group, creating doable list of action that are measurable, meaning that what kind of business are you going to make for your group project? Okay, doable within this semester. Okay, so yeah, the topic will be about your group project. Okay, what will be the topic of your group project that you can do? Okay, not only talking, but you can create that system that can be calibrated, validated, you can demo about it. Okay, so here it is. So you can create a paper or you can use a virtual paper or Word, okay, and you make it into this form. Okay. On the top, you think in terms of problems. Okay. On the bottom, you think in terms of solution. Okay, what business problem that you want to solve? Now, in the solution, you divide into 4 parts. Okay, name it: create, eliminate, okay, increase, and decrease. So you create this kind of form. Okay. In Word, you can create, or you want to use Excel, is up to you. Is it clear? So you have a discussion with your group mate, okay, and you will fill up this form. You create your own form and you will discuss this form. So the discussion, probably about 10 minutes. Okay, you write down the problems and the solution, okay, within the scope of the topic, which is the group project. Okay, and you focus only the top 3 of each color of the block, the most important one. Okay, and then we will discuss about the control and so on. Okay. Is it
Sir.
okay? Yes?
Create is what we want to create, right?
Can you type this? Can you type?
Is it still not good? Sir?
Hello?
Hi.
Hello, hello.
Yes, okay.
Okay, I solved my problem. Okay. Uh, uh, can I see the blue ocean
Sure.
again, sir? Wait,
Sure.
I want to ask something.
Mhm.
Create is what kind of AI that we want to create, right? For the
Hmm.
create box. Yes, sir.
Yes.
Uh, Eliminate, increase, and decrease. What's that?
No, you have a problem, right? You have a business problem. Okay. What will be the problem that you want to solve?
Mm-hmm.
Okay.
Mm-hmm.
Of course, when you create a business, there's a problem that you want to solve through your system, isn't it?
Yeah, yeah.
So now the question is, how are you going? First, you write the problem. After that, for each of this problem, okay, you brainstorm of the solution. Okay, the solution you focus into 4 parts. Okay, first is for solving that problem, how are you going to create? Number 1. Number 2, for solving that problem, how are you going to eliminate something? Not to create, but to eliminate something.
Okay. Okay.
For solving that problem, how are you going to increase something? What is that something? Okay. The solution of that problem is to decrease something. Okay, you write down the top 3.
Okay.
Okay, clear, eh?
Yeah, I think I know how to. Okay. Okay.
Okay.
Okay, I understand how to use this box. Okay, sir.
Good.
Oh.
So after that, you will filter. Okay, the next slide is about filtering of this after you finish. Okay. Go ahead. So I will pause the recording.
Variable, yeah.
Tiga tuh add
Sudah dihapus KB ini.
wait.
No. Hi, sir.
I
Oh.
So do you need more time?
A bit more, I think.
Okay, okay,
A couple of minutes, sir, to finish 2 and 3 of the
okay,
elimination.
okay. Just go ahead then.
Okay.
Udah muncul belum ya? Ya, tulis. If you what you really want. Berarti increase-nya apa?
Nomor 2 dah. Increase. Itu loh. Bukan lah.
Oh ya, efficiency. Jadi dia langsung bisa
Iya.
tahu.
Pinter-pinteran gombes aja.
If you need time, if you need more time, so please go ahead. No problem.
Oh, we are presenting right here, or we present to the whole class?
I think now is not enough time. Then you can continue, and then we will present it next. You will present it next week. Is it okay?
Okay, that's fine.
Okay, sir.
Please continue then.
Okay.
Thank you, sir.
Okay. When you finish, you just leave. Okay.
Okay.
Sure.
How about the attendance?
Oh yeah.
Attendance.
What is present?
I plan to leave the QR code sih.
Everyone is present, Miss.
Huh?
Everyone is present.
Yeah, sure. I can write it manually.
Okay.
Aduh, repot terus.
Oh. Thank you.
Yeah.
Okay, sir, thank you.
Thank you.
So next week you present it, huh?
Okay.
Yes.
Okay. Please continue then.
Yeah.
Please present it next week in that case. Okay, so
Okay.
I will let it open until you finish, then you can leave.
Oh, all right, sir.
Right? Okay.
So we present the topic, the problem and also the solution next week.
Yes.
All right, sir.
All right. So please continue your discussion until it finishes. Okay.
Okay, sir. Thank you.
So when you finish, you just leave the meeting.
All right.
Right.
Oh yeah.
Hello, sir. We've done our discussion.
It's done.
Yes.
Can I see?
Okay. James will share the screen.
Yes. Okay, good. So you can present it to the class next week. Is it okay?
Okay,
Yes.
sir. I think it's okay.
Yeah. So you can continue your discussion today, and when you finish, you just leave.
All right.
All right.
Okay. So we'll give you more time in that case. So go ahead, continue.